How many 3-digit positive integers x are there with the property that x and 2x have only even digits? One such number is 420 for x and 2x equal to 840. And each of x and 2x has only even digits. It is a 3-digit number, correct? And first and foremost, what are the even digits? Well, there's 0, 2, 4, 6, and 8. Those are the only choices that we can use. So no 1, no 3, no 5, no 7, no 9. Okay, so for the first digit of this 3-digit number, my choices are either 2, 4, 6, or 8, right? Can't be a 0 because if it's 0, it's not a 3-digit number. For my second digit, I can use a 0. That's not a problem. And 2, 4, 6, 8. And very similarly, the third digit, you can also use 2, 4, 6, or 8. So first, let me just figure out how many of these will be created. We got 4 choices for the first, 5 for the second, and 5 for the third. So you multiply. 4 times 5 times 5 is 100. Now 100 is one of the answer choices, but hold on for a second before we choose that, because that would be wrong. This 100 reflects all the 3-digit numbers that have only even digits. Fine. But we have to create numbers where 2x also only has even digits. Okay? So if the question was just x, the answer would be 100. But the question is x and 2x. So we immediately cross out 100. I can also cross out 125 because obviously my answer is going to be less than 100, right? Because there's several of these that I have to eliminate. All right, so here we go. How do I eliminate? Well, think about 2x. So this was a scenario for x. Now we got to think about 2x. If any of the numbers or any of the digits is a 0, if I multiply it by 2, it will be 0. So that's not a problem. Same thing, if any of the digits is a 2 in x, if I multiply it by 2, then it'll be 4. That's not a problem. 4 becomes 8, again, not a problem. But 6 becomes 12. And that is a problem because 12 contains the digit 1, which is not even. And similarly, 8, when you multiply it by 2, becomes 16, and that is a problem also. So the 6 and 8 cannot be used when we take into consideration that 2x also has to have even digits. So that means if I have a 3-digit number, for the first digit, I can use only 2 or 4. 6 and 8 cannot be used. For the second digit, I can use 0, 2, or 4. And for the third digit, again, I can use 0, 2, or 4. So now I've got 2 possible choices for the first digit, 3 for the second, and 3 for the third. 2 times 3 times 3 is 18. And that is the correct answer, where both x and 2x will only have even digits. So number 15, the answer is 18, and that is choice B. In the multiplication shown, P and Q each represent a single digit, and the product is 32951. What is the value of P plus Q? 3, 9, and P multiplied by Q3, and that all equals 32951. All right, let's talk about this. So the very first step, of course, in this multiplication, if you're doing it the long way, is you would multiply 3 by P, right? 3P. And 3P equals 1, but obviously 3 times P cannot equal 1. So it equals something that has 1 as its units digit. Well, you think about that for a second. What could P be? Well, P must be 7, because 3 times 7 is 21. And that's why you got the 1 here. 1 is the units digit of 21. Correct? So there you go. With a little bit of thought, we figured out what P is. Now to figure out Q, the simplest way is just to do it like this. 397 is that top number multiplied by some number Q3, well, these are digits, is equal to 32951. All right, get out your calculator, do the division here, 32951 divided by 397, and when you do that, you get 83. So Q3 is 83. That means Q is equal to 8. Right? So they want you to figure out P plus Q. Okay, no problem. P plus Q is equal to 7 plus 8, which is 15. So 15, the answer is 15, and that is choice C. When 5 to the power 35 minus 6 to the power 21 is evaluated, the units digit is. Well, 5 to the power of something. Let's figure out what the units digit is, first of all, just for 5 to the power of something. I'll just do a few. 5 to the power of 1 is 5. That's 25. That's 125. That's 625. That's 3125. So it looks like 5 to the power of anything has a units digit of 5. So this is going to have a units digit of 5. So 5 to the power of 35 will have a units digit of 5. Okay, now we got to think about the 6. 6 to the power of something. So 6 to the power of 1, 6 to the power of 2, 6 to the power of 3, and so on. Let's see, what do we get? 6, 36, 216, 1, 2, 9, 6, 7, 7, 7, 6. Well, as you can see, the units digit of 6 to the power of anything seems to be 6. Except 0, right? Because 6 to the power of 0 would be 1, but you understand what I mean. As long as the exponent is greater than 1. So 6 to the power of 21 will have a units digit of 6. So now this big number minus this big number is really boiling down to a 5 minus a 6. Well, a 5 minus a 6 is negative 1. Well, you obviously can't have negative 1. But what does negative 1 really mean? It means 1 before. It really means a 9. Now, if you're not sure, if you're not convinced of that, let me give an example. And also another thing that I need to mention before giving you an example is that 5 to the power of 35 is much bigger than 6 to the power of 21. So we're having a situation where you have a bigger number subtracting a smaller number. So I'll do that. I'll take a big number and I'll subtract a smaller value of 6 to the power. So let's do that. 3125 minus 216. This is a very similar scenario. And if you do that, what do you get? 3125 minus 216. You get 2909. So you see how the units digit is 9? So that's how you get the answer. And like I'll repeat one more time, that it's only true if this number is greater than that number. And that's very important, because otherwise, if it's not greater, you would actually get a value of 1. So for example, if the 5 to the power was smaller, so if you had something like 25 minus, say, 1296, you would get a different scenario. You would get, in this case, minus 1271, and you see the units digit is 1. So it's 9 because this is much bigger than that. So number 16, the answer is B. In the subtraction question shown, K, L, M, N are digits. What is the value of K plus L plus M plus N? All right, so let's work at this one at a time. L minus 4 is equal to 1. So that means L must be 5. The next one, 0 minus N is 1. Well, that actually means that N is equal to negative 1. But N can't be negative 1, right? Because N is a digit. But you guys obviously know that it doesn't have to be a 0, right? We could have carried the 1. So it actually was a scenario of 10 minus N is equal to 0. Or sorry, equal to 1, right? 10 minus N is equal to 1. So that means that N is 9. Okay, so far we're doing great. So I'm going to write them out. 6K, 0, and L, which is 5. And then subtract M, 9, N, which is 9, 4. And that is 2, 0, 1, 1. And at this point, it's pretty straightforward, I hope. So this column, we can concentrate on that. K minus 9 is equal to 0. But here's the thing. We had carried the 1, remember? So it's actually not going to be a K that's left. It's going to be a K minus 1 that's left. Correct? So we don't actually have K minus 9. We have K minus 1 minus 9. So that means K minus 1 is 9. So this number in here, I can just put a 9. But the thing is, if I did that, I'm actually putting K minus 1. And we don't want to put K minus 1 there. We want to put K. So if K minus 1 is 9, then K must be 10. But K cannot be 10, right? Because K is a single digit. So K obviously must have been a 0. So that means that this number was a 0. And there you go. And if that's a 0, then obviously M must be a 3. So it's just a little bit of fiddling around. And you can see that the numbers are 6005 and 3994. And if you do that subtraction, you indeed get 2001. So now we are responsible for the addition of KLMN. Well, this is K, L, M, and N. So KLMN is going to be 0 plus 5 plus 3 plus 9. And that is 8 plus 9, which is 17. So number 17, the answer is 17, and that is choice A. N is the smallest positive integer whose digits have a product of 1728. Then the sum of the digits of n is 1728. So the first thing we have to do is convert this to prime factors. So that's going to be 2 times 2 times 2 times 2 times 2 times 2 times 3 times 3 times 3, I believe. 2 to the power of 6 times 3 to the power of 3. Okay. So now what we have to do is find out some numbers that we can make a very small n. We want n to be as small as possible, okay? So I've got to, obviously, if I did a number like this, 2, 2, just this straight, just these numbers, these are the digits, let's say, and obviously the product of the digits is equal to 1728, but that's a huge number. It's certainly not going to be the smallest n. The smallest n will be if I'm able to combine some of these guys. So let's fiddle around with this and see what we get. Let's see, how do I approach this? Well, let's see. If I combine these two guys, I get a 9. If I combine these two, I get a 6. If I combine, let's see, these 3, I get an 8, and these 2 will give me a 4. So the smallest integer I can make with these 4, 8, 6, 9 is 4, 6, 8, 9. So if this is my n, the sum of the digits will be 4 plus 6 plus 8 plus 9, and that is 10, 18 plus 9, 27. Okay, so that's one possibility. 27 is one of the answer choices. Okay, but is this the smallest n though? Somehow I think not. Let's go the other way. I started here and went this way, right? Let's go the other way, see if I can get a smaller n. How about if I combine those 3, I get 8. Combine those 3 again, I get 8. Combine those 2, I get a 9. And then this one just by itself. That, if I make an n out of those 4, I can get, the smallest n would be 3, 8, 8, 9. This is indeed small, this number is indeed smaller than this guy. So that's a better n. Now let's see, what is the sum of the digits here? 3 plus 8 plus 8 plus 9, which is 28. I think that's the answer, because this is the smallest possible n, and the sum of the digits is 28. Now don't get confused. The sum of the digits here is greater, but that's okay. N has to be as small as possible. So number 18, the answer is 28, which is choice A. In the addition of two-digit numbers, each blank space, including those in the answer, is to be filled with one of the digits 0 through 6, each used exactly once. The units digit of the sum is. Okay, so I've got to do a lot of trial and error, right? But hopefully not too much. Hopefully there's a system that I can use. Well, what is that system? Well, I don't know. Let's see. Well, the first thing I notice is that the numbers I have to choose from are between 1 and 6 inclusive. Now, they say that when you add up two two-digit numbers, it's going to be a three-digit number. All right? So that means that this number in here has to be at least a 1. It can't be a 0, right? Because if it's a 0, then this is not a three-digit number anymore. It's kind of pointless to put 3 boxes. It'd be misleading too. So this is, I don't know, but I'm going to say that it's at least a 1. So that means that when you add up these two-digit numbers, the sum has to be greater than 100. So for example, if this was 12 and this is 34, that's not going to work because that's going to be what, 46? And 46 is not a three-digit number. The sum has to be at least a three-digit number. Okay, so let's see. Well, I have no idea what this is, so I'm just going to start and go this way. A lot of trial and error here. So 6543. Okay, I have no clue. Let's add this up. This is going to be 108. Okay, well, at least one of my criteria is satisfied, right? I've got a three-digit number. But look at this problem here. I've got an 8. And 8 is not one of the numbers I can choose from. Remember, all the digits have to be between 0 and 6 inclusive when I fill in this box. Okay, no problem. That was just my first attempt. It's not 65 and 43. No problem. That makes me think that when I add up these guys, it's got to be a number in that range, either 0 to 6. Okay, that shouldn't be that difficult. Instead of a 5, let's put in a smaller number. Well, I'm going to put in 2. Let's see. 62 plus 43, that's 105. Guess what? I just did it. That works. All the criteria are filled. I've got all the numbers from 1 to 6, or 0 through 6. And yeah, I'm done. So number 20, they want you to figure out the units digit of the sum. Well, this is the sum right here, and the units digit is 5. So number 20, the answer is D. In the addition problem shown, M, N, P, and Q represent positive digits. When the problem is completed correctly, the value of M plus N plus P plus Q is. All right, so we got to fiddle around with this here. So let's do it one column at a time. We got 3 plus 2 plus Q is equal to 2. Well, obviously it's not going to be equal to 2, so it's most likely equal to 12. So that's 5 plus Q is equal to 12. So that means Q is 7. So Q is 7, and therefore it's 12, so there's going to be a carry, right? So now let's concentrate on that column. That column gives me 1 plus 6 plus P plus 8 is equal to 4. So that's what? This 15 plus P is equal to 4. Well, obviously it's not 4, probably 14, but it's not 14 either, because P has to be positive. It even tells you that in the question. So it's most likely 24. So that means P is 9. And there's going to be a carry, and the carry this time is 2. Now let's concentrate on that column. And might as well include the M in there. So that gives me 2 plus N plus 7 plus 5 is equal to M and then a 0. So this is what? 14 plus N is equal to M plus a 0. And the only way this would work is if N is 6 and M is a 2. It would be 20 is equal to 20. And I encourage you to plug all those numbers back in here and verify. And then M plus N plus P plus Q would be 2 plus 6 plus 9 plus 7. So that's what? 16 plus 8, which is 24. Number 13. The answer is B. How many integers n are there with the property that the product of the digits of n is 0, and n is between 5,000 and 6,000 inclusive? Well, n can be either 5,000 or 6,000, and then we have a whole bunch of possibilities in between. So I'll just put 1 and 1 just to show that that's how many numbers I have. The other possibility is that if you have a number of the form like this, where the 0 is the last digit, and this digit can be anything from 1 to 9. So I got 9 possibilities here and 9 possibilities there. So 9 times 9, I've got 81 possible numbers of this form. Okay? And very similarly, a number could be of this form, where the 0 is here. Again, I got 9 possibilities, 81 numbers of that form. And in a very similar way, the number can be 50 blank blank, where again we have 9 possibilities for those two, again giving 81. And then there's 3 other scenarios. Another scenario is if you have 2 zeros. So for example, if the number looks like this, for this guy, you can put any digit from 1 to 9, so there's 9 possibilities there. The other type of number is if the 0 is there and there with any digit from 1 to 9 in that position. And again, 9 possible ways of making that number. And then finally is when you have 0, 0, and then blank, and again, it'll be 9 possible ways. So I think this covers it all if you add up these guys. So it'd be 1 plus 1 plus 3 times 81 plus 3 times 9. And that looks like 2 plus 243 plus 27. And that is equal to 272. So number 19, the answer is D. How many 7-digit positive integers are made up of 0 and 1 only and are divisible by 6? We have 7 digits and has to be divisible by 6. Well, the only numbers I can put are 0 and 1, so the last digit must be a 0 in order for it to be divisible by 6. If it's a 1, there's no way it'd be divisible by 6, because if multiples of 6 never have a 1 as the last digit. You can try it. You'll see. It'll never be a 1. So I'm confident that the last digit is 0. Now we have to figure out what to do here. Well, if a number is divisible by 6, 6 is equal to 2 times 3. The number is also divisible by 3. So if a number is divisible by 3, the sum of the digits are divisible by 3. Sum of digits is divisible by 3. That's one of the more common divisibility rules. So I've got to place 1s and 0s in a way so that the sum of these digits is divisible by 3. How can I do that? I have a certain number of 0s and a certain number of 1s. All right, let's see what happens here. If I put all 0s, so 6 0s and 0 1s, that's going to work. But it won't, because then we'll have this, which is basically 0, and that's not a positive integer. So that one's gone. How about if I put 3 1s and 3 zeros? That will work, because then it'll be 1 plus 1 plus 1, which is divisible by 3. And the only other way is if you have 6 1s and 0 zeros. The 6 1s basically are like this. So there's only one way of doing that. So there's only one possible way of making that number. But this has a few possibilities. A number where there's 3 1s. So somewhere in here we got to put 3 1s, and somewhere we've got to put 3 zeros. The lead-off number, though, must be a 1. And the reason is because if the lead-off number was a 0, it would no longer be a 7-digit number. It would be a 6-digit number. So we got to put a 1 there. So that means that these guys, I have to put 2 1s and 3 zeros. Okay, so at this point, instead of writing them all out, I'm going to use choose notation. So from the 5 slots, I have to choose 2 to place the 1s. And then from the remaining 3, I choose those 3 to place the zeros. So 5 choose 2 is what? 5 times 4, 20 divided by 2, 10. And 3 choose 3 is just 1. So there you go, 10. So 10 is what goes here. So add them up, 10 plus 1 is 11. There's 11 ways of making this 7-digit positive integer with the conditions of the question. Number 18, the answer is B. 3-digit numbers ABC and DEF have the following property: ABC plus DEF equals 1,000. None of A, B, C, D, or E, or F is 0. What is A plus B plus C plus D plus E plus F? I guess I don't know if there's a scientific way of doing this other than just trial and error. So I just plug in some numbers, and you can plug in any numbers. Like for example, these two, when you add them up, they equal 1,000. And they fit our criteria that none of them are 0. And let's see what the sum is. 1 plus 2 plus 4 plus 8 plus 7 plus 6. If you add those up, it equals 28. So you might think, okay, well, that's great, but what if you have another set of 2 numbers that add up to 1,000? Won't it be different? Well, let's see. Let's choose another one. And like I said, you can choose any one you want. I chose 3, 2, 1. If I do that, then 6, 7, 9. When you add them, you get 1,000. And does it meet my criteria that none of them are 0? Yeah, none of them are 0. And again, 3 plus 2 plus 1 plus 6 plus 7 plus 9 is 28 again. So I'm convinced that 28 is the answer. So in a non-scientific way, just through trial and error and plugging in numbers, we get 28. So number 14, the answer is D.